Alright, so in this video, I'm going to solve the equation k times k times k plus k is equal to 30. So obviously I want to find the value of k in this equation. So to start off, k times k times k is the same thing as k to the power of 3. So k to the power of 3 plus k is equal to 30. And now I'm going to subtract 30 on both sides. So I get k to the power of 3 plus k minus 30 is equal to 0. Now I'm going to rewrite this as k to the power of 3 plus k minus 27 minus 3 is equal to 0. And 27 is the same thing as 3 to the power of 3. So I get k to the power of 3 plus k minus 3 to the power of 3 minus 3 is equal to 0. Now, if I have something in the form a to the power of 3 minus b to the power of 3, this is equal to a minus b times a squared plus ab plus b squared. So this is equal to k minus 3 times k squared plus 3k plus 3 squared, which is 9. And we can't forget our plus k minus 3 at the end, which is this part right here. And this is equal to 0. So now, because both of these terms have k minus 3 in them, I can factor out k minus 3. So I get k minus 3 times k squared plus 3k plus 9 plus 1, because k minus 3 divided by k minus 3 is 1, is equal to 0. So this turns into k minus 3 times k squared plus 3k plus 10 is equal to 0. Now I'm going to divide this into two different equations. I have k minus 3 equals 0, and k squared plus 3k plus 10 is equal to 0. So for k minus 3 equals 0, I can add 3 on both sides. So I get k is equal to 3. So this is one solution of k. And for k squared plus 3k plus 10 equals 0, because this is a quadratic equation, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is 3, and c is 10. So I get k equals negative 3 plus or minus the square root of b squared, which is 9, minus 4, times a, which is 1, times c, which is 10, all over 2a, so 2 times 1. So now this is equal to negative 3 plus or minus the square root of 9 minus 40 over 2, which is equal to negative 3 plus or minus the square root of negative 31 over 2. And I can rewrite this as negative 3 plus or minus the square root of 31i over 2, because I is equal to the square root of negative 1. So this is two more solutions of k. So these are my three solutions. Alright, so in this video, I'm going to solve the equation x to the power of 12 minus 1 is equal to 0. So to solve this, I'm going to first rewrite this as x to the power of 6 to the power of 2 minus 1 squared is equal to 0. And the reason I'm doing this is so I can use the property a squared minus b squared is equal to a plus b times a minus b. So this turns into x to the power of 6 plus 1 times x to the power of 6 minus 1 is equal to 0. So this gives me two equations. I get x to the power of 6 plus 1 equals 0, and x to the power of 6 minus 1 equals 0. Now I'm going to do the same thing again. I'm going to rewrite x to the power of 6 minus 1 equals 0 as x to the power of 3 to the power of 2 minus 1 squared is equal to 0. So I can use this property again and get x to the power of 3 plus 1 times x to the power of 3 minus 1 is equal to 0. Now, for x to the power of 3 minus 1 equals 0, I'm going to rewrite this as x to the power of 3 minus 1 to the power of 3 equals 0, so I can use the property a to the power of 3 minus b to the power of 3 is equal to a minus b times a squared plus ab plus b squared. So this turns into a minus b times a squared plus a plus 1 is equal to 0. Sorry, this turns into x minus 1 times x squared plus x plus 1 is equal to 0, which gives me yet another two equations. So now I have x minus 1 equals 0 and x squared plus x plus 1 equals 0. So for x minus 1 equals 0, all I have to do is add 1 on both sides, and I get x is equal to 1. And for x squared plus x plus 1 equals 0, I can use the quadratic formula. So by using it, I get x is equal to negative 1 plus or minus the square root of 3i over 2. So these are two more solutions. And now we aren't done yet because we also have to solve these. So now I have x to the power of 3 plus 1 is equal to 0. And I'm going to subtract 1 on both sides, so I get x to the power of 3 is equal to negative 1, meaning x is also equal to negative 1. So this is another solution. Now for x to the power of 6 plus 1 equals 0, I'm going to again subtract 1 on both sides. So I get x to the power of 6 is equal to negative 1. And if I take the 6th root, I get x is equal to 6th root of negative 1, which is equal to negative 1 to the power of 1 over 6. So now, the 6th root of negative 1 is, we know that I is equal to the square root of negative 1, which is equal to negative 1 to the power of 1/2. So negative 1 to the power of 1 over 6 is the same thing as negative 1 to the power of 1/2 minus something. So now 1 over 6, or I should say 1/2 minus 1 over 6 is equal to 1 over 3. So 1 over 6 plus 1 over 3 is equal to 1/2. We know this, meaning we have negative 1 to the power of 1 over 6 and this plus, or sorry, 1 over 2 minus 1 over 3 is what we can rewrite 1 over 6 as. Now, this is the same thing as 1/2 plus negative 1 over 3. And if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So this is going to equal negative 1 to the power of 1/2 times negative 1 to the power of negative 1 over 3. Negative 1 to the power of 1/2 is the square root of negative 1, which is equal to I. So we get I times negative 1 to the power of negative 1 over 3, which is the same thing as 1 over negative 1 to the power of 1 over 3, which is equal to negative 1. So I get I times negative 1, which is equal to negative I, which is my final solution.